Mark Stokes, the co-founder and CEO of Magdrive, who are working on building the next generation of space propulsion, laying the infrastructure of a new space age, and interplanetary space travel. So, Mark is a mechanical and deep learning engineer who has worked at startups and Fortune 500 companies, taking prototypes to markets in robotics and aerospace, and is now working on turning humanity into a spacefaring civilization, which is quite intense.
It is, yeah.
So thanks for joining me today.
Thank you very much.
So first of all, definitely want to learn more about Magdrive.
Sure.
What do you do?
So Magdrive is developing the next generation of propulsion for satellites. At the moment, for moving around in space, you kind of have just two options. Chemical propulsion gives you a lot of thrust, but it has very poor efficiency, so very low miles per gallon, or very low kilometers, very low kilograms per kilometer, I guess, you're in Europe. So on the other hand, though, you have electrostatic options, which give you very low thrust, but they give you very high efficiency. And they're both very good at doing completely different things, and there's really no middle ground. What Magdrive are doing is building the first of its kind that provides that high thrust of a chemical system, but with the high efficiency of an electric system. What that does is it enables entirely new business models based on those brand new capabilities. With that, you can start doing long-term operations in very low Earth orbit. You can do long-term, reliable, lasting satellite rendezvous for satellite servicing. You can do inclination changes, deliberate inclination changes, 15 to 20 degrees, and all of that is necessary to start building up towards a new space age, where we use resources in space, we manufacture them in space, we assemble the infrastructure in space as well, and start bringing all of the necessary industrialization into one place in orbit.
That sounds very incredible. And now I'm kind of curious about your journey with Magdrive, because we've been in touch for a while now, and Magdrive kind of was born into this whole COVID age.
Yeah.
How was that? What are your stages of development that you've gone through now?
At the very first stage, it was me and my fantastic co-founder, Thomas Clayton. We started off just moonlighting it. A couple of nights a week, we get together, we try out some very basic assumptions about the technology. We started networking very heavily with the UK Space Agency, the Satellite Applications Catapult, who've been fantastic in helping us out. And around the time COVID hit, we found a means to go full-time. So then we were pretty much isolated from each other completely. We started calling each other a lot because we couldn't meet up. And we started to split the roles a little more clearly. Thomas worked more on the technology, demonstrating the first steps of our power system and generating our first plasma in his spare bedroom because he just Iron Man the hell of it. On the other side, I started learning as much about the market as possible, seeing where the capabilities that we knew we could build would fit into that, whether people would actually want to buy this thing, what their current needs were, what their problems were. We built a lot of assumptions around the current limitations of propulsion systems, and we had to know that we were going to be able to solve them. We had a lot of anecdotal information, but being able to work with people in government as well as in primes and SMEs, and especially people who have roles bridging those two gaps, helped us a lot there. My role developed from that into taking the lead as we spoke to venture capitalists raising our first round of funding. And a lot of startups founders will say they don't like raising money, but I loved it. I loved talking about Magdrive for half-hour bursts to VCs who would listen. And because we raised in 2 months, I think that's true. If we'd done it in 6 months or longer, probably the shine would have worn off a little bit. So my role has transitioned from a very mechanical aspect. In the early days when me and Tom managed everything together, now that we are a team of 8, my role is much more on the commercial side of things, making sure that the engineers we have, who are fantastic, have all the tools that they need to do the work they do, and also making sure that we continue to raise Magdrive's profile, that we have a long-term strategy, and that everything aligns towards getting the Magdrive to market. So I'm constantly thinking somewhere between 3 to 6 to 12 months in the future.
Okay. And do you think that the whole COVID situation gave you a bit of a boost because I mean you have grown very quickly, or did you see it more as a challenge that needed to be overcome as well?
It was a challenge that we had to essentially work separately, but it helped a lot with raising money in this very capital intensive industry.
Mm-hmm.
It was great that pretty much any VC was happy to pick up the phone or pick up the Zoom and talk for just half an hour. When before you would have had to speak to that person like in person.
Mm-hmm.
We sometimes did 6, 7 VC calls in a day, and that would have been impossible before COVID. Now that we have moved out of a previous lab, which was governed by the UK Science and Research Council, now that we're in our own space, there are no limitations on when people can come to work. So we have COVID measures and always have had these COVID measures in place, and have really accepted flexible working into the way all the engineers work, as well as ourselves, so that if they know they're going to be sat in front of a computer just doing CAD work or documentation all day, well, then they can work from home. But the reality is there's a lot of lab work to be done, and doing that in person in the lab and making that access easy and making everyone feel safe has been the most important thing to occur.
Yeah. And now I'm curious because I mean the goal behind this or the vision to create like the propulsion for a new space age, that sounds amazing. How did you get to that point? What was the inspiration there?
Yeah. The inspiration there, that's credit to Thomas. Thomas, his background is in plasma laboratory astrophysics. He's also worked in nuclear fusion and has an excellent grasp of a lot of topics which combine all these technical aspects together. We discussed for a long time what we wanted to do in the space industry and where we could make the most change. And his idea initially was a entirely electric, single-stage orbit, reusable launch vehicle. 20% payload mass, says the maths.
Mm-hmm.
And we started looking at this thing and thinking that actually we can't build this. This is going to be insanely expensive. We're first-time founders. We've not raised money before. We don't have those kind of connections. So we approached it more from an engineering point of view.
Mm-hmm.
Looking then at how do we distill this down to an engineering challenge? What are the really core components of the technology that we can build and demonstrate at a very small level, reduce all the complexity as much as possible? Like maintaining magnetic fields of 40 Tesla, we're a long way off doing that as a civilization, let alone as a company. So we needed to demonstrate that we can contain the plasma as efficiently as we're aiming to, that we can have an efficient and miniaturized pulse power system that we're working towards right now. So the next step for us really is to demonstrate this kind of technology in space. So at the moment, a lot of our time is being taken up by building towards our first flight. The hardware is being delivered before the end of the year, and we'll be in space with our first prototype in May, June of next year. And our engineers have put a lot of work into it. They're all exceptionally talented, and it couldn't be happening without them. So right now, and in my ideal world into the future, they will always be the heart of a very technical aspect of Magdrive in the future as well. Because as we continue to scale up, we want to build a bigger Magdrive. Mm-hmm. We want to build a version which can be 30 kilograms heavy instead, and it will do 50, 60 times the thrust. It has a lot of engineering challenges to it, but these guys, the current team, are the best to do that next step and then continue to build up back up to the original vision of a single stage to orbit, reusable electric plasma launch vehicle, which, give us 30, 40 years. We'll get there.
I love that you're staying true to the core inspiration of what led you here. And also now, because it seems like it's a very niche idea, and you seem to have a really good team behind you. But what are certain barriers to entry that you've realized, especially when trying to create a startup in the space industry?
The main, most obvious one is that it's a really capital-intensive field. Mm-hmm. You're probably looking at needing at least £1 million, $1 million, euro, whatever, to get from your concept on paper to something which can be demonstrated in the lab. Say around TRL6, demonstrating that it works in the lab, that you can do environmental tests well, let alone getting your flight heritage, which of course in the space industry is crucial to demonstrating that you actually know what you're doing to a certain degree, that you can actually do the least of what you need to do to be a genuine space company. securing that kind of funding is difficult. It's hard, noticeably because the investment scene, although it's very active in space, it's mostly active in the United States in that way, and it's also very active towards launch, for example. Propulsion systems have not attracted that level of investment in general compared to launch services, because there's been no outstanding innovation in this area for quite a while. This is technology that's reached the top of its S-curve, and improvements have always been about reducing mass, getting slight improvements out of efficiency for chemical thrusters, for example.
Do you see this trend changing now?
Yeah, definitely. Launch itself may turn out to be a bit of a bubble. There are like 150 launch companies right now, and they can't all survive. They can't all survive for the next 10, 20 years. But the space industry is a really horizontal industry compared to what it was 10, 15 years ago. So that, plus the advent of extremely space-capable off-the-shelf electronics, means that anyone with an idea or a concept can get that off the paper into the lab and can start demonstrating that. And as these investors and VCs who maybe are a little later to the scene can start looking around the rest of the industry and start identifying where major improvements can be made in, pretty much across the board, where the advantage is that there's already this supply chain and logistics chain in place. Satellites need propulsion systems, and we're plugging right into that. The real challenge and the real skill is being shown by companies like Varda, for example, which are proposing something entirely new and building a completely new valuable supply chain into that. But they're building up on top of all the extra improvements that are being made to the space industry right now, and that all feeds back into that capital need, which, it's hardware costs. It's not being able to just farm out your development to some guys in the Ukraine for 6 months, which I envy. That would be great. But I wouldn't know them either, so there's a downside.
That's it. You see, for other startups that are looking to enter the space sector, that if they fit themselves into these already existing supply chains and value chains, the barriers to entry are relatively easy to overcome them?
I think so. I think there's an advantage there to show that you can make a magnitude improvement, specifically in the way that, say, a tech lead at some SME or prime chooses a product. And they choose products for propulsion systems, power systems, ground stations. And if you can make those demonstrable improvements, then they will want to see those included in that technology, in their supply chain overall. The extra kind of challenge in particular, as well as building this technology, which in certain ways we are writing the book on, the challenge is keeping everything tight in terms of timeline. We know how much money we have, we know how long that's going to keep Magdrive going for. So we have to plan for what can we demonstrate in that period of time? Who needs to be, in blunt terms, who do we really need to impress in that period of time so that we can secure the future for Magdrive off the back of that? And that includes looking both at grant opportunities, it means working with established companies, and it means building a constant relationship with venture capital so that we can demonstrate to them, you gave us $2 million in December of 2020. Since then, we've built this incredible team, and they have gone forward to produce thrust measurements. We've got a prototype in space. If you give more, here's our pitch of what more we could do. So keeping those relationships fresh, keeping that news constant as well as constantly trying to keep that whole vision, technical and commercial strategy together, is the extra challenge you find in hardware, because you need to make it industry specific as well.
But I think those are also then some good lessons learned of certain steps that need to be taken into consideration, especially also kind of being always one step ahead of what needs to be done next.
Definitely. And that one step is, in the space industry, one step is like 6 months. Yeah.
Good to know. Good to plan. Now, stepping slightly away from Magdrive and looking more at your own personal journey. So from my own experience, I've noticed that you don't really choose space. Space chooses you. So how were you chosen for space?
That's a good question. I guess very early on, I really wanted to work in something which was innately cool you go to a job interview and they ask you, why do you want to work in X industry? And I really struggled to find an answer that wasn't just so cool. And I found that basically applied to space and brains. So I studied mechanical engineering, and I deliberately went to Imperial College actually to study neurotechnology. When I got there, I discovered actually it's an MSc in deep learning, and you just use brain signals to do that, which is fine because I still don't know anything about biology, really. Lots of cool facts about the brain, but nothing tangible. But it kept up the dream of wanting to make a difference in space, wanting to reach a kind of a sci-fi goal and work towards that. I attended an exhibition which was really designed to bring together MBA students with engineering students from Imperial College, and I presented an idea about a concept I had for constructing satellites in space. The core technology was zero gravity, 3D printing, metal sintering, etc. And that's where I met Thomas. And instead of talking to any MBA students, me and Tom just talked for like 2.5 hours about our passion for space, about how we wanted to build something together, and we found that our common interests really led themselves to that. So I think the moment space chose me was when I met Tom, and when we just clicked and talked about how we both really wanted to be our own bosses, to lead development of something towards a goal which is so lofty that it will take the rest of our lives to achieve. That's still true today, and it's the backbone of everything that we agree on together. We never want to sell this company, because at the heart of it, it's a project which has just taken the form of the company instead.
That's really wonderful. It's also nice that Thomas is your very own space messenger to get you into this.
Yes. If he's watching this right now, don't cringe, Tom.
Cringe a
little bit.
Yes, so one thing that I find very interesting to also talk about and to really hone in is the accessibility to the space sector, and how do you get into the space sector? Because it's fascinating, and definitely it's cool just to say you're in space. That's awesome. But how to really put that into practice? So I would want to know, what do you look for in like an employee or a colleague? What are like the main considerations you take when hiring someone?
I was always initially cautious about answering this question, because my route to space, how did you get into space? It sounds callous or like cavalier, but actually just found a company, and that's how you get into space apparently. But it plays very much into how we choose, or how what kind of person we want to join the Magdrive team. A passion for space is really at the heart of it, and we would also look for people who've engaged with space societies, who've had experience on working on space-related projects, who know about the space industry, who keep up with the news like that. But what we've found is that we don't need to hire dedicated space engineers. In a few instances, it's been extremely valuable. Some members of the team have experience of working in the industry already, and they bring a unique perspective to what we're building and a real experience that we can lean on. But other engineers in the company, for them, they have a very particular set of knowledge around power electronics, for example, or rapidly prototyping mechanical engineering. So even though they've not worked in space before, they know that they can work to a set of requirements. They know they can work towards a particular aim, and that will be fine. Because the reality is there are so many aspects that go now into what puts a satellite together, what puts a propulsion system together, that someone who has a background purely in space won't be able to achieve. The Magdrive team has power electronics, rapidly prototyping mechanical engineering, flight engineering, plasma diagnostics, computational plasma physics. And what ties it all together is this passion for space, which is the first thing we look for, is that does the team get the vision and the message, and do they see why me and Tom can never put this down? The other thing is, it's around the startup mentality as well. You can do long hours, and you've got to love the work that you're doing, and hey, you want to also the team also owns part of Magdrive, which is really important for me as well, to have that ownership. A certain mentality as an engineer comes into it a lot, engineer or scientist really, which is that because we give the team a lot of freedom. It's the best way for us to work, really. When they work on a particular component, they have the freedom to make really important design decisions, which, they come to me or Tom and say they need this to work, to make their jobs easier, or they think this is the best way forwards. We'll discuss it together as a group, and that decision can be made and carried forward and becomes part of the overall design. So they get a huge amount of agency. With that, the flip side of that, of course, is owning failure. Mm-hmm. And I'm inspired when I see the guys run into something which doesn't work and they just move past it. A lesson is learned, they internalize it, and they just move forwards. I really admire that, and I really appreciate it. The third aspect is more just social. 8 people in a team, spend a lot of time together, so you've got to just get on. So in the very early days, we thought, can we just go for a drink with this person who we want to make part of the team? And that evolved into me asking the question, have you ever played Dungeons and Dragons before? And it's true to say that everybody who's joined the Magdrive team had a very positive reaction to that question. Either they had played or they would like to play. And, we try to play every 2 weeks now, which is great because it really breaks down the whole work talk. Everybody becomes a character and everybody goes on these crazy mad adventuring quests. And I get to DM, which is, a personal passion of mine. So it's great. To say that Magdrive is a vehicle for playing more D&D is not entirely untrue.
Sounds like the most amazing job interview ever.
Yeah.
Want to be part of the Magdrive team.
Also, play some D&D with us.
Yeah. Definitely up for that. So, your route to space was somewhat unconventional. Just like, hey, let's start a company, and suddenly you're in there. What other conventional or unconventional paths have you come across for other people entering this field?
Yeah. I think the really important thing to notice there is that space, with the way the industry grows now, it's not just engineers or scientists. It needs people who understand policy. It needs people who understand education, outreach, PR, marketing, operations. The entire strategy of building up a company which is embedded in a huge industry is massive. And it needs all of those roles to work as well. I think the unconventional routes that I've seen are people who've started working in those areas in other adjacent industries. So maybe in engineering as well, but also in sustainable development. Whether they've worked in policy, for example, and they've just touched on space a little bit. What I've noticed in common is that these people start attending events about space. And there are so many. There's events through the Satellite Applications Catapults. Astro Agency runs a space bar every 2 weeks, just to name 2. And the people at these events are extremely friendly and extremely accommodating. And you can very quickly become part of a network of people who can recommend jobs or recommend more networking. They recommend that you go and talk to this other person. And you'd be amazed at how rapidly things just snowball out of showing an interest and having your own solid founded opinion and having a good conversation with someone can lead to a new job, can lead to transferring your skills to some company in the space industry. Because every company in the space industry is going to need that specialization.
Very true. Now for my final question before we move on to some audience questions, it's a bit of a loaded one. We're looking at the future. And since we are at the World Summit AI, we're also looking at how AI could impact this. So what is the main future development you see in the space sector, or that you want to see?
Sure.
And how could AI contribute to that? Or do you see it contribute to that?
I think there's definitely a role for AI there. A few options come to mind. Computer vision has always taken a bit of a backseat in space. It's got its own real distinct challenges, considering that access to data is much harder. Also, your power budget is hugely constrained in space. I've previously worked in that kind of edge AI, coming from a background where power is never a constraint, and then being told you have 5 watts to run this entire system is mad, and it changes everything that it's a completely different way of building all our infrastructure and architecture for machine learning, deep learning, and computer vision. So advances in edge AI will really open up computer vision for space, which is really important for satellite rendezvous, satellite servicing, being able to apply the techniques we've perfected on Earth to space as well.
Mm-hmm.
Navigation is another area which I think it can help a lot. With Magdrive, for example, there's scope in the future for us to expand out of propulsion and start offering that more as a service. So the Magdrive, say, detaches from its host satellite. It can move somewhere else with its very long lifetime. It can work for another one. It can take the host satellite to wherever it needs to go. And that there is another subset of AI where that kind of AI assist can really help towards making the most efficient decisions for wherever that satellite is and where it then needs to go. More broadly in space, I want to see it becoming much more horizontal. I want to see it becoming much more democratized in terms of returns. It's very true right now that the countries which are really at the forefront of space innovation, because they have the infrastructure, like the US, China, are already disproportionately reaping the benefits of every type of innovation in space. So certain pushes and agendas that can be done through the UN, like for example SDG 18, which I know you're co-founder of, something like that, which is aimed very much towards sustainable long-term goals and spreading that aspect of accessibility to poorer countries, giving them the access.
Mm-hmm.
Because it's very unlikely that a poorer country in a remote part of the world can build the infrastructure that it needs, because it's hugely expensive. And the talent probably doesn't exist in the same way that it does in the US, which has built this up for decades. So being able to take part in those is going to require new organizations. It's going to require new ways of thinking about how we bring those countries in and what kind of returns they want to see, so that this access to space, so the improvements we make over there, and as we build towards that new space age where we move heavy industry to space, where we start to build better electronics, better medicine, that applies to everybody and not just the most developed countries, which contributed the most to the space, to a shared space program overall as well. So those kind of programs through the UN, through Sustainable Development Goals, can push a lot of that and really change the way that, as a civilization, we do become spacefaring. That there's a real possibility wherein, say, 20, 30 years' time, maybe 5 or 6 companies can pretty much run the solar system. That kind of contribution also has to become accessible. And while I very much believe that with the magnitude change that Magdrive is making to propulsion, that we could be one of the biggest companies of the 21st century, I want the work that we do to impact not just massive other corporations and governments on Earth that obviously will generate benefits from it. I want that to go to other countries as well, where people can say, hey, I want to take part in this. And there's a very clear route for them to do so as well.
Very nice. I think that is an amazing view to have. And yeah, coming from SDG 18, also highly appreciated to see that that's in the private sector as well. So fantastic. Really nice. Thank you so much for taking the time, for coming from the UK